Hello, today we're going to be doing lesson 7.2.11, and we're starting out here with a graph. As you can see, this is a proportional relationship. You need to invent a situation that could be represented by this graph and describe your situation in the box below. So please go ahead, take a look at it, and create your own situation. All right, so I created a situation where um, my x-axis represents cups of dog food and my y-axis represents the cups of cat food. And so this graph shows how many cups of food my dog eats compared to the amount of cups that my cat eats. And so I even described what this point meant because it's point 1612. So for every 16 cups of food that my dog eats, my cat eats 12 cups. You do not, of course, have to have this situation. As long as yours is a proportional relationship, then it will make sense. All right, so again, I've actually kind of worked ahead here, right? So here's a graph that represents the relationship we just talked about. And the point on the graph is, again, it's 16 because x comes first, and 12 because y is the second coordinate. And I need to type that in. Now, it is important that in order for this to show up as correct, you have to use the parentheses. It- well, let's see. Let's try this. I've made mistakes. Let's see if this works. Okay, so not only do you have to use parentheses, you also cannot put a space behind the comma. So you literally have to type it in just like that. Okay? Now, if you scroll down, it says explain what the coordinates mean in the situation you invented on slide 1. And I already said that for every 16 cups that my dog eats, my cat eats 12 cups. Okay. And again, your situation is going to be different um, for whatever it is that you chose. Okay. All right. So now we're going to be looking at Tyler's walk. We'll be doing this later in a different we'll be using this situation in lesson 12 as well. So let's get used to Tyler's walk here. He's at an amusement park and he walked at a steady pace. So the word steady tells me that he's walking at a constant rate at the same speed. He's not like speeding up and then slowing down. It's just a constant speed from the ticket booth to the bumper cars. And the point on the graph shows his arrival. So that means when he got to the bumper cars. What do the coordinates of the point tell us about the situation? So we have to be able to interpret graphs when we are looking at proportional relationships. And what that means is we have to pay attention. Here is our y axis, right? And we know that that is the distance from the ticket booth in meters. And our x-axis represents time, elapsed time. Now, elapsed is just a fancy way of saying uh, time that's already gone by, right? It's in the past, like how long it took, okay? So we have to look at the coordinates. So in here, it's 40, 50, right? Um, and explain what that means. So what I'm going to do here is I'm going to take a marker and mark down, whoops, best I can, to the x-axis. And so this point tells me that in 40 seconds, right, because that's where it goes down here, and then now I'm going to trace it over here. So in 40 seconds, Tyler went, because this is a distance, 50 meters, right? So you can see how I did that, okay? So let's go ahead and make sure that we write that in this box. Okay. And the way I explained it was that the coordinates tell me that Tyler walked 50 meters in 40 seconds from the ticket booth to the bumper cars. Um, the other thing this kind of tells me that since this is his arrival at the ticket booth, we know that that ticket booth is 50 meters from the um, the bumper cars are 50 meters from the ticket booth. Okay, so that's kind of important to know. Okay, so let's take a look here. Now we have a table, right? And it's representing Tyler's walk and shows other values of time and distance. Complete the table to show how far Tyler walked, and it says plot the pairs of values on the grid. So, as you can see, most of this is filled in for us. And what this kind of shows us is, he walked at a steady pace from the ticket booth to the bumper cars. And so we know first, his first time, and remember, this is the X, right? Time is X, distance is Y. His first time was at 0 seconds. He had gone 0 meters, right? Meaning he was actually at the ticket booth. And if I wanted to plot this, since this is already in here, I literally have to go to, this is the X value, right? So this is our X values. This is our Y. So these become actual coordinates. So 0, 0 is 0, 0. We can then come over and plot it onto our graph. And I know 0, 0 is the origin, right? So I'm going to put my point here. There's my first point. Okay. Since he's walking at a steady pace, we now know his second coordinate that they've given us is that after 20 seconds, Tyler went 25 meters, right? So 20 is my X value because remember, when we plot points, this is what they are. The first coordinate is the X value. The second coordinate is the Y value. So we're going to find that 20 is on the X, and I can even write this in to help remind myself. So we go to 20 seconds, and then it went up to 25. Things to notice is that my scale is what we call it. This is 0 and this is 10, which means the one in between has to be 5. So I know these are going up by 5. 5, 10, 15, 20, 25, 30, and so on. Same thing down here, 5, 10, 15, 20. Okay, the next point is 30, 37.5. Now, this one I have students who go, I don't know what to do because, well, let's try it out. 30 seconds. So we go to 30 seconds, and then we have to go up our Y axis to 37.5. And so I have students who often go, wait a second, there is no 37.5 listed here, right? So this is where we have to use what we know, okay? And so we know that 37.5 has to be between 35. So we're starting at 30. So here's 35, right? And here's 40 on that 30-second time. And so we have to be able to know that 37 is more than 35, right? So it's above 35, but it's also less than 40. And really, it's going to be probably somewhere in here. Okay. So that's how I plot that point to know. All right. Another little trick that you might consider is that, whoops, that's not what I meant to do. Another trick that you might consider is that I know that this is a proportional relationship, right? And I remember, proportional relationships make a straight line from the origin. So that can sometimes help me know where to plot these as well. So I know it kind of has to be lined up with these other points. Okay. 40, 50 is already on our graph. It's right here, right? So they already gave that to us. Now, we do have to figure out this time. So if this is true, how far does Tyler go in 1 second? Okay. This is where we need to find the COP, right? It's a constant relationship. So we have to figure out how is this changing? So obviously, hopefully you remember to find the constant of proportionality. All you really have to do is you're thinking, okay, what do I multiply these first column by to get to the Y column, right? So 40 times what is 50, 30 times what is 37.5, 20 times what is 25, and it should all be the same number. So really, I could use any of these pairs. I'm going to use the 40 and 50. So I remember to find out what I multiply 40 by to get 50 means I take the 50 and I actually divide it by 40. And that will tell me what I multiply 40 by. So here I know it's 1 and 25 hundredths. Okay. So that is my COP. And so now we have to plot that. And again, I have students who go, oh my gosh, 1 isn't on here. And it's like 1.25 isn't on here. Well, we know it's got to be really close to the 0, right? Because it's between 0 and 5 for the 1. So it's probably going to be pretty close. And then the 1.25, same thing. This is really very close to my origin, right? So here we have it. We have all of our pairs plotted. We have our COP, right? We filled in the chart. We know that Tyler is walking 1.25 meters for every second. So let's see what's next. Actually, I'm curious. I want to see what this does. Oh, okay, cool. I like that. Anyway, sorry, I saw that and wanted to know what was going on. So let's go ahead and try out our next slide. All right. So what did 0, 0 mean in that situation? We had actually already talked about that. 0, 0 means that Tyler was still at the ticket booth, right? And had walked 0 seconds and 0 meters. Okay. So that's what the origin meant in this case. Okay. How far away from the ticket booth was Tyler after 1 second? Well, we had already done that, right? After 1 second in our table, Tyler had gone, and it says to label the point on the graph. That's this point here, which is hard to see, but that is 1.25, right? We had found that earlier. So type your answer in the box. So it's 1.25. Let's see if this checks the work. All right. And I'm wondering if I put meters, just in case some of you do that. All right. Technically, I would like to see meters in here, but it will still mark it correct if you haven't. Okay. All right. Now, what's the constant of proportionality for the relationship between the time and the distance? Well, we had already talked about this, right? The COP is the number that we would have multiplied all, and I'm going to go back to the table. The COP is the number we multiply all of the X column by to get to the Y. And we had found that here when we did um, when we did 50 divided by 40, right? So we figured out, oh, we had to multiply this by 1.25, which means I had to multiply the 1 by that, which means that this 30 times 1.25 is 37.5. We could even check that out. So 30 times 1.25 should give us 37.5, and it does, right? So we know our COP is 1.25 or 1 and 25 hundredths. Okay, so it's 1.25. Okay, now what does it tell us about Tyler's walk? Well, remember when we did this on the graph, the point was 1 and then 1.25. In the table, it was 1 second, right? Because X was seconds and Y was the meters. So that tells us in Tyler's walk, it took Tyler 1 second to go 1.25 meters. Okay. And if we go back to our graph, where do we see it? Well, we see it at this point here, right? The point where our X is 1 and our Y ends up being that COP. So it is 0.1, 1.25 on the graph. Okay. All right. So let's keep going. All right. So now, and actually, I'm going to go back to this, one of our objectives in this lesson is to understand that on any proportional relationship, the point 1, so when x is 1, and I'm going to put that down here. When x is 1, the y value is actually going to be k. All right. And again, this is only for proportional relationship graphs. And when I say k, hopefully you remember that is the COP. That's the letter we use for COP, right? Remember the equation for proportional relationships looks like y equals k, or the COP, times x. Okay? And so we know no matter what, if we figure out what the 1 is for the x value, we know the y value will be the COP for that graph. Okay? We're going to use that to move on. So now we have a totally different situation. We have seagulls eating trash. What a lovely sight that is, right? So 4 seagulls ate 10 pounds of garbage. Assume this information describes a proportional relationship. Okay, so plot a point that shows the number of seagulls and the amount of garbage they ate. So this is the information they gave us. 4 seagulls ate 10 pounds. I need to come over here and decide, okay, what's the x representing in this graph? And when I see it, oh, okay, the x is the number of seagulls. Cool. And the y is the pounds of garbage that they eat. So I know 4 seagulls. So I'm going to come over to 4, ate 10 pounds of trash. So I have to go all the way up to 10. And here's that point, right? And then it says use the line tool to draw a line through this point and 0. 0, sorry. So this is where we have to remember that they're telling us it's a proportional relationship. And we know the graph of a proportional relationship is going to be a straight line, right? That goes through the origin. So that's why we're connecting the origin, which I know it can be hard to get these connected, but do your best to get them exact. And I'm actually going to make this go through that point. All right. So here we go. We have a proportional line that's representing this situation. Okay. So let's move on. So they have copied exactly what I put over there. And so it says on the sketch pad, plot the point 1K on the line. So what that means is for this, remember 1K simply means what is the K? What's the Y value, which is in this case, the K is the COP, when the number of seagulls is 1, where does that hit this line? Okay, so that's what they're telling me. And here's what I'm going to do. I'm going to draw a line. You don't have to do this, but I'm going to do this. So here's the 1 seagull, right? So I know I'm looking along the line, and I'm looking for the point where this number 1 seagulls goes across our line that we drew. Okay, and so let's see here. I'm thinking it goes right here is what I'm seeing. So what I'm going to do now is I'm going to take that. That's going to tell us, oh, okay, when there's 1 seagull, I follow that up to the line, come over, and the Y value is, in this case, it looks like to me it's exactly between 2 and 3. So I know that that's 2.5 or 2 5/10. Okay. And again, I didn't do any math calculations. I just used the graph, right? So now what does the value of K tell you? Remember K is the COP. So what's it tell us about the story, right? So the K, and I'm going to say or COP, is 2 5/10, which means that 1 seagull, because that's the X, right? The X is showing number of seagulls, can eat 2.5 pounds of trash or garbage. Okay. So that's actually what it's telling me in the story. Next, it says, write an equation to represent the situation. Use n to represent the number of seagulls. So I'm actually going to write that, in this is x is actually n, right? Because it's the number of seagulls. And g is my y, which is representing the trash or garbage, okay? So that, again, this is where I can use what I know. If I know the COP is 2.5, right? So the COP is 2.5. I also know it's proportional, right? So I know that the y, remember I use y equals k times x, no matter what, in these situations, if you take x and you multiply it by the COP, you get y, right? So I'm going to do that, except for now, they didn't use x and y. So I'm going to kind of put in place what they did use. So instead of y, they're saying that the garbage is equal to the constant of proportionality, which is 2.5, times x, which isn't x, it's the number of seagulls. This should be the equation that works, right? So let's see here. G equals 2.5 n. It is worth noting that sometimes people write it as 2.5 n equals g. That's totally fine. You could also write it as 2.5. Let's see here. 2.5 times n equals g. And it's going to come up as wrong. Let's see here. Technically, this is right. Okay, I would accept this. They're just making sure when they're writing it in this Desmos, they're saying, let's write it like a mathematician. So instead of doing 2.5 times n, we just put it together like so. Okay. All right, let's move on. Okay, these are just challenge slides. All right, so what I'm going to do is I'm going to go through to the next, I'm going to go to the summary for the whole lesson, and then I'll go back to those challenge slides to help you understand what's going on there. Okay, so in summary, what is special about the y coordinate that goes with the x coordinate of 1 on a proportional graph, right? The thing that's special about it is the y coordinate is the COP when the x coordinate is 1, right? That's the special thing, right? 1k. 1 is the x, k is the y value, which is the COP, okay? That's the summary of this lesson. You should be able to look at a graph and know, oh, okay, the COP goes with the y coordinate. So now let's take a look here at the challenge 1. All right. Challenge is change the COP, the constant of proportionality, so that the purple marble collects all the stars. Then select the launch button to see how you did. Okay. So basically, when we're looking at this, I'm knowing the only thing that's going to change here is the number, right? Because it's y is equal to the COP times the x value. So right now it's at 2, and it looks like to me um, it's not quite high enough, right? Because we want this green line to go through this purple and the two and the stars. So let's see. Let's try 1 and see what happens. Okay. When I hit 1, that actually made my line go less steep, right? So okay, we had 2, so now let's try 3. All right, and we had success, right? Good stuff. All right, so let's try here. Let's see what it says. What is the value of y when x is 1? So what that means is this is our equation, right? So if x is 1, it would be 3 times 1. So y is 3 in this case. Okay. What was your successful equation on challenge 1? Well, we said y equals 3x. Okay. Try the next one. Okay, this one's a little different. So they started again with y equals 2x. And I remember from the last one, when I made it 3, it actually got steeper, right? When I made it 1, okay, it got lower, right? So now we have to get this marble to drop and collect these. So I have to keep going lower than 1. Okay, so that means it's a fraction. So how about 0.5? Half of 1. That wasn't enough, was it? All right, let's try zero point 0.1. Okay, that was too much. Okay, let's try 0.2. Okay, now here's what I have. I had a lot of students who they did this and they were like, yeah, okay, there we go. We got it, right? Um, and actually, let's see. What happened when we did 0.1? Okay, yeah, 0.1 was too low. It didn't catch those stars. All right, so we had 0.2. And then let's see what happened here. For here, we know that what's the value of y when x is 1? Well, that would be 1 times 0.2. So that would be 0.2 or 2/10. And they get it wrong. Okay. And then so I had students go, but that's not true because when I did this at 0.2, it totally collected them. Right. Here's what I'm going to say about that. When you look at this, okay, the stars, the line does not go through the middle of these stars. So it's close, it'll collect the stars, but it doesn't actually fit these stars as a line. So zero point 0.3 was too much, zero point 0.2 is not enough. Let's try the middle. That would be 25 hundredths. Okay, and the reason I knew that is because 0.2 is also 20 hundredths, 0.3, whoops, is also 30 hundredths. So in the middle of 20 and 30 is 25. Now let's try this. It does collect all the stars still. And then now let's try this. There we go. We got it. So our successful equation was y equals 0.25x. And there's your challenge. So hopefully you feel a little more confident about using graphs and being able to find this COP.